Good morning, dear students. In the last lecture, we have seen different types or methods of HVDC transmission system. And after that, we have seen uninterruptible power supply. So what is the need of uninterruptible power supply? Then features, important features or main features of UPS that already we have seen in last lecture. Then this is a generalized block diagram of UPS. Then already we have seen online UPS in the last lecture, but again we'll repeat and then we will go for the second part or maybe a next time. So this is an online UPS that is also called as inverter preferred UPS. Sorry. In this UPS, there are two types of switches called as a main static switch and UPS static switch. Actually, both are the SCR, but the name or notations are given as a main static switch, which is directly connected between the supply and load. So that is called as a main static switch. And another is a UPS static switch, which is connected through inverter to the load. Okay. So in this particular online UPS, the load is always feed through inverter, and that's why it is called as inverter preferred online UPS or UPS, right? So in this system or in this UPS, single phase or three phase, depending upon your power requirements, AC is applied to the rectifier or called as a converter, which converts AC into DC, and that DC is used to charge the battery bank, as well as the same DC is fed to the inverter. So that inverter convert that DC into AC. Okay, definitely the output of inverter is not a pure sine wave, it's a square wave. So some filter circuit, some wave shaping circuits are added, and after getting maybe close to sine wave, that's output of inverter is applied to the load through UPS static switch. So UPS static switch are continuously on and main static switch are continuously off. Okay, in this figure, the UPS static switch and main static switch are shown. So they are basically a SCR, right? So if you are using SCR as a switch, definitely the protection circuit, then triggering circuit is required to these particular switches. Okay, but for simplicity or to avoid the complications in a figure, that triggering circuit and protection circuits are not shown. Okay, now in this particular circuit diagram, it works in two modes. The first mode, supply feed to the rectifier, convert into the DC. That voltage is given to the battery charger, right? And then directly given to the inverter. Inverter convert DC into AC, and through UPS static switch, load is connected. Okay. Then second mode, when AC fails, then the DC voltage applied to the inverter, that is from battery bank, because the battery bank is charged, fully charged through the rectifier and charger when mains is on or mains is present, right? So battery DC voltage is applied to the inverter convert that into the AC, and through UPS switch, the load is fed. This is the second mode. If your UPS static switch or inverter fails or battery discharge, if battery discharge, right, then that time the supply voltage directly single phase or three phase through main static switch. If inverter fails or battery discharge, that time UPS static switch turns off automatically because anode voltage is equal to 0, and at the same time main static switch turns on and load is fed from single or three phase supply directly. Okay, so this is a working of online UPS that is given here in a mode 1, mode 2 and mode 3. In case of if UPS fails, then normally off main static switch is turned on, which automatically transfer the AC line to the load in the less than 1/4 cycle period with no phase discontinuity. 1/4 cycle period means what? How much time actually is called 1/4 cycle period? So anyone, those who are present for the lecture, they can give the answer. 1/4 cycle period. It means how much time? And this is most important actually, switching time. Switching time, it means when UPS fail, main switch on. When mains fail, then UPS switches on. But whatever the time to turn on the switches, that time is given in terms of 1/4 cycle period. It means how much time? Yes. Anyone unmute and tell me how much time 1/4 cycle period means? How much time? Yes. Santosh, Santosh Andhale, Mega. Okay.
Yes, sir.
How much time if it is called 1/4 cycle?
Cycle
Okay,
period,
Manoj has
cycle.
given answer 90°, but Manoj, I want time, that is conversion of 90° into the time for a complete cycle. Answer is correct, but uh, not in appropriate format. Manoj given answer, definitely it's a correct answer, but not in a proper format. Santosh, how much time? 1/4 cycle period. So again, Manoj give an answer 15 seconds, but it's not correct, Manoj. Anyone? See,
35.
this is most important. That's why I'm asking you, because you should know that how much time required to turn on the switches, because it's a UPS. It means that without discontinuous power supply, that is given here, even no phase discontinuity, right? So within a same phase, within a same time, your UPS or main switches turns on if UPS fails. So that time period is given as a 1/4 cycle period. It means how much time? How much time for total cycle, one cycle? If frequency is of 50 hertz, because it's a line frequency. So 50 hertz frequency. So how much time for one cycle? How much time for one cycle? How much time for one cycle? 1/50 hertz equal to 20 millisecond. 20 millisecond is the time for one cycle. So it is called 1/4 cycle period. It means 5 milliseconds. So yesterday, when we discussed about the UPS, that time I told you that the time period of Microsoft inverter is less than 8 milliseconds, right? If you see the switching time on the box of a Microsoft inverter, then it is given as 8 millisecond, or I think less than of 8 millisecond. So 1/4 cycle period, it means that 5 millisecond. So time to turn on the switches is only 5 or less than 5 milliseconds, then and then only you will get a continuity in the supply, right? That is no phase discontinuity, or you can say continuity in a power supply, right? This is not only maintain the power to the load, but also actuate the failure alarm signal to draw attention of the attendant. This type of system is more popular because it can provide full isolation of critical load from AC line and also provide power conditioning, right? The main advantage, the system protects the critical load against surge, spikes, line noise, frequency, and voltage variation. What is the reason or which circuit actually protect these the critical load against surges, spikes, line noise, frequency, voltage variation? Is there any idea in your mind how this circuit will protect your load, critical load, from these may be called as some harm situations. Yes, anyone? See, this above circuit, it is online UPS protects your load against surges. It means any high current or voltage surge, then spikes, then line noise, then frequency and voltage variation, right? Why this above circuit is capable to protect your load from these situations? Do you have any idea how this circuit will protect your load? This above online UPS. See, these are the advantages of online UPS. I'll just explain you how this circuit will protect your critical load, because the mains is continuously off. Okay, mains is continuously off. It means that the supply is not given directly to the load from supply. Okay, that is a source, input source. So these main switches are continuously off. So what happens? This AC voltage is converted into DC first. So automatically voltage spikes, any surge is removed. Then after that, it convert again into the AC with the help of inverter. If you are using proper inverter, for example, PWM inverter, then definitely the noise at the output of PWM inverter is zero. Then PWM inverter itself control the any high voltage spikes, because the input to the inverter is the DC, so no voltage spikes will appear at the output of inverter, right? And that's why the online UPS having the advantages. The system protect the critical load against surge, spike, line noise, because the load is not directly connected to the line at all times. In case of UPS failure or battery discharge, then definitely the load is fed directly from the supply. But normally, in the normal situation, the main static switch are continuously off, so it is not fed from the main source. So automatically line noise is reduced. Frequency and voltage variation. As already we know that the supply voltage having 50 hertz frequency, that converted into the DC, and after this DC is given to the inverter. So inverter may having variable voltage or variable frequency. That is possible. Already we learned the inverter circuit which produce variable voltage as well as variable frequency, right? So these are the advantages of online UPS, and it works in a three different modes. Okay, then next one is offline UPS. You can see here the online UPS and offline UPS. If you see the circuit diagram is same for online and offline UPS. No change. A slight change, that is main static switch is normally on. Here the main static switch is normally on and UPS static switch is normally off. You can see here the above diagram. The main static switch is normally off in online UPS, right? And UPS is normally on. Okay, this is the online UPS, and in offline UPS, it is exactly opposite. Main static switch is normally on in all conditions, and UPS static switch is normally off, right? If main fails, only that time UPS static switch is turns on. So remaining circuitry is same. The working is also same. You can see the working is very similar to that of online UPS. Only what happens in this circuit, the mains is given to the rectifier and charger. It charge the battery. Okay. But because of this UPS switch is normally off, the output of inverter is not connected to the load. Right. Even battery charges, and whenever it fully charged, then automatically shut down, and the load is fed directly with the supply through these switches to the load. This is normal condition. If suppose the mains fail, if your mains shut down, right, only in that situation the main static switch turns off. Main static switch turns off. Okay, and that the static that is UPS static switch turns on. Only that condition. Okay, it turns on and the supply feed to the load via battery inverter, it converts into the AC, and then through these switches the supply is given to the load. So this is offline UPS. It is called as a line preferred because the normally line is connected to the load. So this type of UPS is not used for critical loads. This type of inverters are not used for critical loads like CNC machine or any other. So block diagram of offline UPS can be observed that only difference between offline and online UPS is that the main static switch here is normally on. It connects to the AC main directly to the load when mains is on. The battery charger is stabilized one which maintain the battery on float at fully charged condition. It means that if battery is fully charged, it automatically turns off and at the same time period stabilize power to the inverter. The other static switch called UPS static switch is normally off switch. It is closed, it is closed, it is closed only when mains fail. It is closed only when mains fails. Thus, in the offline UPS, the inverter comes into the circuitry only when the mains fail. Otherwise, the output of inverter is zero. Then remaining part, again, the time cycle is given as a 5 millisecond, that is switching time. If main fails, the UPS static switch turns on in a less than of 5 milliseconds. Okay, the online UPS, the advantages of online UPS. Normally what happens, I'll just explain you disadvantage of offline UPS so you can understand the advantages of online UPS. Okay, so first disadvantage of offline UPS, you cannot connect critical load to the output of offline UPS because the supply voltage is directly feed to the load, right? And this input supply, input source is not a constant voltage. We all are very aware about the input voltage or source, single phase or three phase, it is continuously variable. If you measure voltage at your home by using multimeter in AC mode, then you will find that the source voltage is continuously unstable. It means it shows 230, within a second it shows 225, 230, even 240, 250, even 210 and so on, right? So line voltage is fluctuated at all times, right? It is fluctuated at all times. Okay, so this line voltage is fluctuated so that you cannot connect critical load. We know that this line voltage is AC voltage, right? But this voltage, AC voltage, it may sometimes increase or high voltage spikes may appear because of maybe a EMI interference or any other type of interference. So that voltage or that spikes will be appear across your load that may damage your load, and that is given here. So the system protect the critical load against surge, spikes, line noise. Line noise, it means that your AC supply has maybe the 50 hertz to 30 volt, but it includes some additional voltage and frequencies, right? Maybe any kind of noise may add with the supply voltage and that will appear across the load, which may damage your load. Okay, then frequency and voltage variation. Okay, so see here, as we know that even frequency is a 50 hertz constant frequency of a supply or line voltage, but it may changes due to any uh, unwanted noise may added into the frequency. Okay, even voltage is continuously variable. If you check by using multimeter in AC mode, you will find that the AC, single phase or three phase, is not a constant voltage, right? So that are the disadvantages of offline UPS, because the load is directly fed through the line voltage, right? And because of that, the critical load you cannot connect to the offline UPS. Now in the online UPS, what happens exactly? In online UPS, this single phase or three phase, I'm saying unstable for voltage, unstable for sometimes frequency, then maybe noise added, EMI interference added. So this AC voltage is unstable, but this voltage is applied to the converter. After conversion, there will be a filter which remove the noise, spike, surge, etc. And pure DC will apply to the inverter input. Right? Here you will get a pure DC. Pure DC. I'm saying pure DC. Right? And because of that pure DC, if input is pure DC, the output of inverter will be close to pure AC, right? It is basically stabilized because the DC is a constant. Definitely the output of inverter is also constant. No fluctuation in the voltage, no fluctuation in the frequency, because the output frequency of inverter we can control. Already we learned that the frequency of inverter can be controlled, right? So if frequency is controlled, then definitely the frequency is constant, voltage is constant, even conversion of AC DC is done here. So any kind of spikes will appear, that will be attenuated at this rectifier circuit itself, right? Any kind of spikes or maybe a surge, if appear, this circuit will protect. And then the constant voltage and constant frequency without any noise, because if you are using PWM scheme, then definitely the harmonic components are also eliminated. So the output through this is actually a switch only. So what is the output of inverter directly feed to the load, which is constant AC, constant frequency, without any interference, without any noise, and so on. So that is the advantages of online UPS. Simply in single words, online UPS is not directly fed through the supply. It is through these circuits. So with the help of the inverter circuit, we can control the voltage, we can control the frequency, we can control the noise, we can minimize the noise, we can minimize the harmonic components, and so on, right? So these are the advantages which are mentioned here. This circuit will provide the above advantages, right? And these are the disadvantages of offline UPS. You cannot use this offline UPS for critical load, because the load is continuously fed through the AC mains, and this AC mains is not a constant voltage, not even constant frequency. It added maybe many type of interferences and so on. So for critical load, offline UPS is not preferred. It is used for normal load, but for critical load, here no isolation provided between the load and mains. Hence, this UPS is not recommended for highly critical loads, because no isolation. Directly supply is given to the load through these switches. It's simply a switch. So no isolation between the load and supply. If supply voltage increases, then load may get damaged, right? So such type of UPS are not used for highly critical loads. Next one is line interactive UPS. So this UPS, uh, the heart of the system is a battery charger cum inverter, which acts as an inverter. In this system, normally the critical load is supplied from the commercial supply through static switch and inductance. The operation of this system can be divided into two modes. Mode one, mains on. When mains on, this is supply actually. So when mains on, main head is switch on, then supply directly given to the critical load via these switches and inductor, high value of inductor. So this inductor will oppose any high fluctuation changes. Actually, this is nothing but a filter, inductor filter. So in this line interactive UPS and offline UPS, in between these two, only one inductor is added here. You can see here the switch and an inductor. This inductor act as a filter. So it block any high voltage or high current spikes and directly feed to the critical load. At the same time, this is given to the inverter come charger which charge the batteries. Okay. Mode 1, when mains is on, the static switch is closed and load gets connected directly to the AC main through the inductor. The inverter charger block operates as a charger and charge the battery bank. The equivalent circuit as shown in figure. First one, AC main static switch is on, supply directly given to the load as well as supply given to the battery bank through charger, so that battery will be get charged. Right. This is the first mode. Then second mode is called as a switch off. Mains off. As soon as the mains fail, the static switch is turns off and inverter charger block operates as an inverter and the battery supplied power. So if it is fails, then only the inverter will provide load supply to the load, right? Through this battery bank or battery and inverter. So this is called second one is called, third one is a line interactive inverter. Uh, the total time taken for sensing and changeover after failure of mains is less than 5 milliseconds. The configuration does not provide any isolation between the load and AC mains. However, it is possible to give pure clean voltage to the load with a good voltage regulation by using power conditioner like AC stabilizer or a constant voltage transformer. So here we can connect AC stabilizer in this particular point or a constant voltage transformer so that we can use the same line interactive UPS for critical load, but without stabilizer and without maybe a transformer, anyone actually, you can use either stabilizer or either constant voltage transformer here at the output of this inductor, then you can directly connect critical load. Otherwise, you cannot connect critical load in the line interactive UPS. Okay. Then next application as per your unit number 6 is a battery charger. Because why the battery charger is given here? Because battery bank and battery charger already we have learned in previous topic. So now what is actually a battery charger? That we have to learn here. Critical loads means critical load, it means like CNC machines or any other load where the precision is required, right? For example, your conveyor belt. Okay, so if you are operate your conveyor belt by using UPS, and if you are using offline UPS, then because of line voltage increases, the load voltage applied to the load will also increases, and because of that, the motor which operates on that voltage maybe rotates more rotation. If you are using stepper motor for conveyor belt, then definitely it will operate for the more number of steps. Even if you are using this particular supply voltage through UPS, basically for CNC machine, and if you are connecting any job on CNC machine, because CNC machine required a very precision or accurate DC voltage so that it can operate on that particular uh, job. Otherwise, your job may be failure. Now you nowadays the laser cutting machines are available, so that laser machine or cutting machines uh, that operates on a constant voltage, constant AC voltage, right? So you require a constant AC voltage. You cannot use UPS. Even if you directly apply line voltage to the CNC machine, then definitely your job, whatever job you connect to the CNC machine or laser cutting machine, then definitely, basically, critical load, nothing but a motor, right? Or maybe a machines which cut the some sections precisely, right? So again, we can say motor, but which required a constant AC voltage, constant, sharp, and even constant frequency. So that type of loads are called as a critical loads. Okay. So next is battery charger. Already battery charger block we have seen in a previous topic. 2-3 times I told battery charger, but exactly battery charger means what, how it works, and even in your mobile, there will be a auto shutdown, because nowadays, if you connect your charger for a night, whole night, even still your mobile work properly, or the battery will not be damaged, right? It is because of automatic charging system. This is automatic charging system. Whenever battery is fully charged, the charger is automatically disconnected to the battery, right? And that is given here. So in this battery charger, you can see supply voltage, then step down transformer, which converts 15 0 15 volt, 15 0 15 volt. It's a step down center tap transformer. Diode D1 D2 forms a conventional full rectifier, right? Then this diode D3, Zener diode, and R, this forms a triggering circuit to the SCR1, forms a triggering circuit to the SCR1. Okay, and SCR1 is used to charge the battery from the supply voltage. Okay, so what happens exactly in this circuit? Then I'll just show you the automatic battery charger circuit using SCR as shown in figure. A 12 volt discharge battery is connected in a circuit. So this is maybe, consider that the battery is a 12 volt and discharge battery. When switch S1 is closed, this switch S1 is closed, then circuit is completed, right? Otherwise, circuit is incomplete. Close. The single phase 230 volt supply is stepped down by center tap transformer. Diode D1, D2 forms full rectifier, so that the output or voltage at the point P and Q, you will get a DC voltage of 15 volt. Okay. Now, what happens whenever the switch is closed, the current will flow through the R, right? Here we are connected Zener diode of a 12 volt. It means that the Zener diode will be turns on at 12 volt. Below that, it remains turns off. So this switch is called off switch. So this voltage will appear across or at the anode of D3. As soon as the voltage at D3 is greater than 0.7, diode D3 turns on, right? Then 1 volt plus 1 volt, or whatever the SCR voltage, gate voltage required to turn on the SCR, as soon as you apply our voltage at the point O, I'll just read it. When SCR is off, its cathode is held at the potential of discharge battery. During each positive half cycle, when the potential of O, point O, rises to the sufficient level so as to forward bias D3 and gate the cathode junction of SCR, right? See, supply voltage is given. The voltage at the P with respect to Q is a positive voltage. This will feed to the diode D3 and then to the gate cathode voltage, right? Whenever the voltage at O is greater than 0.7, diode D3 on. Then current start to flow. Whenever the voltage at the SCR is greater than the actual VGS, that is gate cathode voltage, VGK. So it is approximately 1 volt, 2 volt, 5 volt, 10 volt. It depends upon the value of SCR. So whenever the voltage increases, SCR turns on, and then current start to flow through SCR, through this R2, and battery start to charge. Your battery start to charge. See, sufficient level so as to forward by D3 and gate cathode junction of SCR1. The gate pulse is provided to the SCR and it turns on. When SCR turns on, the charging current flow through the battery. Thus, during each positive half cycle of pulsing DC voltage across PQ, SCR is triggered and charging current pass till the end of half cycle, right? So this is when the battery is fully charged. This is important. When the battery is fully charged, the cathode of SCR is held at 12 volt. Therefore, diode D3 and gate cathode junction of SCR cannot be forward biased, since the potential of O is equal to 12 volt and potential at cathode is also 12 volt. So O12, cathode 12, SCR will never conduct, right? So once battery is fully charged, then SCR will never conduct. If SCR never conduct, then battery overcharging of battery is avoided. Hence, no gate current is supplied and SCR is not triggered. In this way, after full charging, further charging is automatically stopped. Right? Last 1 minute is remaining. Give your attendance in a chat box fast. Give your attendance in a chat box. Last 1 minute is remaining. Fast. Everyone, give your attendance in a chat box. Okay. After that, I think two topics are remaining. That is, one is electronic ballast and another is, I think, induction heating. So that two topics we will cover in the next lecture. So most probably at on Friday 27, we will complete our syllabus, all 6 units. Okay, already 7 practicals I posted on YouTube. You have to see all 7 practicals. If you need to explain it again, then I will explain you in a class. Okay, and